All right, team. Sorry for talking at you so much today. I promise these notes are going to be quick and painless so that we can get into some practice and really be ready for tomorrow when we talk about polynomial division. But in order to talk about polynomial division, we need to understand how we do polynomial addition and subtraction and multiplication and all the other operations with polynomials. And so our notes today are simply going to be a review of polynomial addition, subtraction, and multiplication. You can see generally, actually, each of these operations is going to follow some similar steps. You do the operation, you add, subtract, multiply, whatever. Then you simplify by combining like terms so that your ultimate answer will be some polynomial, and that polynomial should be in standard form. So should be in the standard form that we just talked about for the first part of our notes today, where everything's multiplied out, terms are in order from biggest exponent to smallest exponent. So let's go ahead and see what that looks like. We'll start with polynomial addition. So in order to do polynomial addition, one thing we can think about is like this first polynomial, negative 10x squared plus x, is being added to this second polynomial. Technically, this addition sign, this plus 1 that is out front of this second polynomial, you can think about that as being like distributed to each of the terms in this second polynomial that's being added. Well, when we do that, we're left with our first polynomial, negative 10x squared plus x, plus 1 times negative 2x squared. Well, that's still going to give me negative 2x squared. Plus 1 times 9x is plus 9x. Plus 1 times positive 7 is plus 7. And what do we notice? Our polynomials are just about the same, except we got rid of the parentheses, and this plus in between kind of goes away. Because what really matters is that the signs of each of the terms in our polynomial that's being added, this negative 2x squared plus 9x plus 7, each of those signs stays the exact same. Negative 2x squared, positive 9x, and positive 7. And so that's really nice thing about addition. You kind of just take it at face value. So we've performed the operation, we've added these two polynomials together, and now we need to simplify by combining like terms. And when we are looking for like terms, again, this is like a mega review, but I'm going to mention it anyways. That means that our variables for each term need to be the exact same. And if they are, we can combine those. For example, if I'm looking at this first term, negative 10, x squared. I'm looking for any other terms in this polynomial that have a variable that is exactly x squared. And I see that for negative 2x squared, and that looks like that's it. Because these two terms have the exact same variable, we can combine them into one term. Negative 10x squared minus 2x squared, that is negative 12x squared. Another way you can think about it, if that's a little confusing, is like treating this x squared as something. Like, what if it was oranges? I have, well, the negative doesn't make sense, but negative 10 oranges minus 2 oranges gets me negative 12 oranges. If that is easier to think about than just like x squared or some variable. Let's go ahead and continue. My next term, it looks like I have an x. So I'm looking for any other terms that have a variable of an x, and I see that this plus 9x is the same. Combine those like terms, plus 1 plus 9. It's going to give me plus 10x. And then the last term I'm left with is a constant, which is kind of like, oh, I'm kind of highlighting nothing. There is no variable that's visible there. And so that's what's going to end up on the end of my polynomial here, plus 7. And that is going to be my response because it is in standard form. All of my terms are combined. They're in order from biggest exponent to smallest exponent. That is what I mean by simplifying by combining like terms. We're going to do the same thing for subtraction. Perform the operation. I have one polynomial being subtracted from the other. When we think about distributing this negative 1, to my second polynomial, similar to what we did before, except now it's a negative one, what we notice is going to happen is our first polynomial stays the exact same, negative 8x squared plus 10x plus 4. The signs of my terms in my second polynomial that's being subtracted, they're going to change because negative 1 times negative 4x gets me positive 4x. Negative 1 times positive 10 gets me negative 10. The signs of the terms in this second polynomial have changed. That is the key with subtraction. Everything else stays the exact same as far as process goes from addition. And so if we are combining like terms, I'll go ahead and give us a chance to do that, and then we can check our work with what I have here in a second. And when I combine like terms, put this polynomial into standard form, I should get what I have here boxed in black. Negative 8x squared plus 14x minus 6. And that is addition and subtraction of polynomials. Pretty straightforward. Multiplication, it is not more complicated, but I think there's more work to be shown, and because of that, it's easier for us to mess up. And so when we're thinking about multiplying two polynomials together, we have a binomial, which is playing off that vocab we introduced at the end of our intro, because there are two terms, times a trinomial, a polynomial with three terms. We have to think about a ton of distribution. This 3x has to be multiplied by every single term in my second polynomial. This plus 4 also has to be multiplied by every single term in this second polynomial. That's a lot of arrows. That is a lot of multiplication, a lot of distributing. Folks, the best way to help organize this work is by using an area model. And I promise you, this area model is going to keep coming up all unit for multiplication and some division, which we'll get to in a second. And so I think it's super helpful and super necessary to organize our multiplication with an area chart or an area model. The way I do that is by placing both of these polynomials, these things that I'm multiplying together, on one side of my area model. So this 3x plus 4 placed on the left side of my area model. 2x squared plus 5x minus 6 placed on the top of my area model. What this allows me to do in addition to organizing is I think it really helps break down the problems that you are focused on like one piece at a time. For example, when we're trying to figure out what is in this box, all I'm focused on are what row I'm in and what column I'm in. And I'm multiplying those two things together. So 3x times 2x squared is going to get me 6x cubed. If I'm focused on this square down here, again, all I care about, what row am I in, what column am I in? 4 times 2x squared gets me 8x squared. In this box here, 3x times 5x gets me 15x squared. In this bottom middle box, 5x, because that's my column, times 4, which is my row, is 20x. And then we'll finish off the last two. Negative 6 times 3x is negative 18x. Negative 6 times 4 is negative 24. My answer, what I get when I multiply these two polynomials together, is everything that's inside of my area model. And so I'm just going to literally pull out every single box that I just did. So I'm going to start with the first row and then move on to the second row. 6x cubed plus 15x squared minus 18x plus 8x squared. Now moving on to my second row. Plus 20x minus 24. All I did was just pull each of the terms from each of the boxes in my area model and laid them all out here. Now we're literally in the same spot that we were before with addition and subtraction. Process is the same. Combine like terms so that we have our polynomial in standard form. I'm going to have you do that for me right now. We'll see what you get. And when I combine my like terms, I've shown some of my color coding work here, just in case that helps us, I should get what I have boxed in green. This cubic polynomial, because its degree, its highest exponent is 3. So again, using our vocab, that I have here boxed in green. And that is 3x plus 4 times 2x squared plus 5x minus 6. All right, that is what today is focused on. We'll go ahead and finish up with one little quick thing on division, and then we'll do some work time before our mastery check. Nice work today, team.